What is given? He has given the acceleration of Planck. Just for our understanding purpose, I made a diagram like this. Otherwise, straight away, we should start with that one only. Okay, now get into the, so this is the, there's a chord or a string, whatever you want, you can take it. Acceleration of a plank, like this, I think, acceleration of a conveyor belt, it is. This acceleration of center of mass, so that is G. Inner area, outer area, he has given. Wire, no? This is wire. Nice problem to really, for students to learn this one. It's a very good, you can think random way, you have to cross check and you have to correct itself. That's what the requirement of this particular problem. Now, what are the forces that will be acting on it? So this wire, the string will become taut. Okay, there's a thing. So tension will be there. This one. Will there be any? So the plank or the conveyor belt will move. So what that particular spool? So this is a spool. So where is the spool? This is a spool. Huh? What is everything? A string is wound on the, say like a shaft of the spool. Then it is connected to wall. And that particular spool is placed on conveyor belt, where conveyor belt will have acceleration AC. Now is asking all this, determine initial tension and angular acceleration of the spool. The spool is originally at rest. Say this particular belt, what happened? This is at rest. You go back to Newton's laws of motion, inertia of rest. So this will continue to be in state of rest, and this is in motion. It will continue to be in inertial motion. The moment this conveyor belt will start, as it starts moving, the spool will oppose its motion. So therefore, the friction should be in this direction. The friction on the spool will be in this direction. Okay, I think I helped enough on this one. At least looking at this, in what action the spool, center of mass of spool should move, and in what action it should have angular acceleration. I think that information is what not there. We are supposed to make a guess. Anybody, can you tell what action the center of mass of the spool should move? Towards left or towards right or any other direction? Let me check it. Left. Left or right? Okay, I assumed it. Let me give towards right. If you want, you can oppose me also. I assume like this. So now you have to give reason. So why only like this? So let me assume towards left. Okay, you do that and try to verify. Whatever you assume and try to verify. In the end answer, try to verify it. If you get negative, you should change the direction. Okay, and for no slipping, the acceleration of these 2 points for no slipping, AC should be equal to R alpha G minus AG. There's a for no slipping between the belt and the spool. There's a one thing. Then T minus F MAG, then F into R How many unknowns are there? Check it once. I need one more equation. Am I right? The aggression of this point should be equal to this one. So if you're getting confusion, I'll introduce points so that it'll be easy for you. For no slipping, AP2 should be equal to AP1. For no slipping between spool and belt. Okay, got the idea? So this is the from here is what I brought that relationship. Okay, now check it like is it our problem got over? How many unknowns are there? So substitute AG value, substitute alpha G value, and AC is given for T and F are unknown, both are unknown. So we have how many unknowns? 4 unknowns are there, and 3 equations. I need one more equation. From where? One more equation. I'll take help of this wire. Aggression of this point should be equal to aggression. What is the aggression of this point? Aggression of this point should be 0. So let me proceed like this. The aggression of this point, let me write, this is P3. Aggression of this P3, and let me take this is P4. Aggression of point P3 along x-axis should be equal to aggression of point P4. Aggression of point P4 must be 0. So aggression of point P3 along x-axis must be 0. Any reason? Things should be taut and inextensible. So AP3X. So AP3X, what is AP3X? We can write it as AG minus R alpha G. Solve it. If you get negative, change the direction. And we assume no slipping, no calculate friction. Friction should be less than the limiting friction. What is the limiting friction? Mu S N. What is the normal reaction? So 500 kg as given. Check it now. Fs equal to check again the value of F. There should be rolling friction. No, it should be less than limiting friction. If it is less than limiting friction, okay, what will you assume? If it is greater than this, in fact, slipping occurs. Then kinetic friction will act here. Then we know kinetic friction. Okay, then you can work out the numerical in other way. I'll give the answer, sir. Later on, you can check it. This is the determine the initial tension, no? 2.32 kilonewton or 23 angular acceleration 1 meter per second square. Verify answer later on. Huh? Let me take to the next problem. Read the question. Carefully, this is